Can meaningful IoT applications really be built and deployed in minutes? In this video, we'll show you an IoT Edge application we built and deployed from scratch in just about 30 minutes using only the OmniAut SoftHub platform. Then in part 2 of the video, we'll show you exactly how easy the application was to build. Our demonstration will obviously be a bit contrived and it will only touch on a fraction of what the SoftHub is capable of, but it should give you an idea of how you can use the SoftHub to quickly build your own IoT Edge infrastructure. Let's say you have a set of sensors you want to collect data from. You have one ANT sensor, which is a Garmin Tempe sensor, and two Bluetooth Low Energy sensors, a Texas Instruments sensor tag, and a Nordic Thingy 52. You want to collect the temperature data from the Tempe sensor, the ambient light level data from the sensor tag, and the current barometric pressure from the Thingy 52. Lastly, you want to forward all that data to a remote server for archiving and further analysis. To do this, you'll obviously need a hub or gateway device to connect to the sensors and to handle the forwarding of the packets to the remote packet capture server. In our example, we'll use a very inexpensive Raspberry Pi Zero, which will be running the SoftHub application. But let's say you also want to give someone in the room being monitored a degree of control over which sensor's data is being sent at any given time. So you add a button that they can press to cycle through the different reporting modes and an LED to indicate the current reporting mode. Each press of the button cycles through 5 modes. In mode 0, no data will be sent and the LED will be off. In mode 1, data from all 3 sensors will be sent and the LED will be on solid. In mode 2, only the Tempe sensor's data will be sent and the LED will blink slowly. In mode 3, the sensor tag sensor's data will be sent and the LED will blink faster. And lastly, in mode 4, only the Thingy 52 sensor's data will be sent and the LED will blink very fast. For the example, we'll also need a remote server to act as our packet capture server. We've configured an AWS cloud server instance to run the OmniAut packet capture service, and we've connected to it via a remote desktop session. The packet capture service is listening on a TLS encrypted port we configured to receive the raw sensor packets from the SoftHub. We're running the service in a debug mode in a console window so that as each packet is received and decoded, it will be written to the screen in an eye-readable XML format. We've already started our application on the SoftHub and are in mode 0, so let's press the button and initiate a transition from mode 0 to mode 1. As you can see, the LED is now on solid, and in the screen capture, packets from all 3 sensors are now being forwarded to our remote packet capture server. We'll press the button again, and the LED changes to a slow blink, and now only packets from the Garmin Tempe sensor are being forwarded. And now to mode 3, where the LED speeds up, and only the sensor tag packets are being forwarded. And then to mode 4, where the LED blinks very fast and only the Thingy 52's packets are being forwarded. And we'll cycle back to mode 0, where again no packets are being forwarded. And then back to mode 1, where all packets are again being forwarded. If you've ever been tasked with building a similar application, you'll recognize that even with the help of the many third-party APIs available, a relatively straightforward application such as this will still require a lot of expensive and time-consuming work. But as mentioned previously, with the SoftHub platform, we were able to create and deploy our application in about 30 minutes, a tiny fraction of the time and effort it would take using virtually any other approach. And we did it without writing a single line of code. Instead, we configured our example scenario to be carried out by the object-based rule engine built into the SoftHub application. Part 2 of this video goes into the details of the configuration process as well as the specific configuration file used in this demo. But before we go, we want to give you a quick high-level look at the rule set used. Here we're running the SoftHub configuration utility and have opened the configuration file used in the demo. At the heart of building a configuration rule set, you identify a set of events you want to react to, and then for each event, you build a list of 1 or more rules to be evaluated when the event occurs. To underscore how simple it was to create the rule set for our demo, our complete scenario was implemented by creating only 14 rules triggered by only 9 events. So to quickly summarize the process we went through to set up the demo, we first ran the SoftHub configuration utility on a desktop to create the SoftHub configuration file. We then copied that file onto the device running the SoftHub application, which in our demo was the Raspberry Pi Zero. Lastly, we restarted the SoftHub daemon on the device, which in turn read in and began executing the configuration rule set. That wraps up the first part of our Developer's Crash Course demo. Please check out part 2 of this video, where we'll give a quick overview of the configuration file contents and take a detailed look at the rule set used in the demo. Thanks for watching.